All right, let's get into some applications of geometry here. And we're going to start with some perimeter and area. And so we're going to start by looking at the side of the house. Here's my house addition that I've been working on and building this part of the house here. And when we're building a house, we get some walls like this big wall right here. It's a big pentagon looking thing here. And we got a bunch of windows in the way. And we got to figure out the area of this siding here, these boards that are getting attached there. And so area is a very useful thing to figure out because these boards will have a certain amount of coverage, all right? So let's try a little simplified problem like this here, all right? So we want to find the area of this wall. So first we can notice we got a pentagon similar to that shape of that side of the house I was just pointing out there. And so we probably don't have an area formula or not familiar with an area formula for a wall like this or pentagon. So we need to break this into some familiar shapes. So let me draw a line. Let me make that a little larger maybe so we can see it better. So let's break this into two shapes. And let's go like this. Here we go. Whoa, let's make that a little wider. Anyways, see that red line there? So we've got to think of this as a rectangle and a triangle, all right? So you've got this rectangle down here and this triangle up here. All right. Now, we're going to have an area formula that we need to look. And in the back of our book, we have some area formulas that you can use there. The area of a triangle is 1/2 base times height. So hopefully something that we remember from some previous classes. The base is this side and the height would be the perpendicular distance from the top of the triangle to the base. All right, so the base has to be one side of the triangle. Great. So, all right. Well, and a rectangle, we're familiar with that. The area of a rectangle is length times width. All right, so we can find the area of this rectangle. And so the question is, do we know the base and the height of this triangle? Well, we know this is 22 feet because that's the same as this guy down here. What's the height, though? Well, right here we're told the pitch of the roof. That's 812. That's a pretty steep roof. My roof over here is a slope of 5/12. But we can find this out now. See this little triangle here? That's a rise and a run. So we need a rise. The rise is the height, and the run would be this distance, which is 1/2 of 22. So this is 11 feet, and so we've got to make a proportion to find the height. 8 is to 12, that's the slope, as the height, which we don't know, this rise is to this run, is to 11. Real close there. All right, and these are in feet here. So we're going to have to cross multiply here. And let's see. So we can solve this up with a little cross multiply. 8 times 11, that's 88 equals 12h divided by 12. Going to get a decimal here, so let's go on over to decimals here. We have 88 divided by 12. So this is just our scientific calculator, desmos.com. Scientific calculator gives us 7.333 feet, okay? We can leave this in feet for right now. That's fine. 7.333. We'll keep several of those. All right, so we don't need it in feet and inches right now. So this height is 7.33 feet. Okay, that's H. Great. So we can find the area of the triangle, we can find the area of the rectangle. Now, we can do this two ways, all right? I'm going to do it kind of the long way, well, or the two-step way. Let's call it that, the two-step way, and then going to show you kind of the preferred one-step way that we want to move into. All right? So the area of the triangle is going to be 1/2 times 22 times the height, which was 7.3333. Okay? And so we go back over here to our calculator, and we can compute that. We have 1/2 times 22 is the base, times that 7.333. I'm going to put answer, A&S is answer. That brings that down in there, gives you the last answer. And we get to, there you go, 80.6 repeating, all right? So that's great, 80.66, and we got to round off to 7 at some point. So this is, all right, 80.66, and we got to cut it off and round it off at some point. So then the area of the rectangle, well, that's going to be 22 times 10. So we have area of the rectangle is 22 times 10, which is 220. All right, great. Now we need the total area. Total area, we got to add those up. And so we have 220 plus 80.66. Now this was pretty nice. We didn't really need a calculator for that because 220 plus 80 is 300, right? So 300, yeah, 300.66. And that is feet. Don't forget your units. Okay. So we found the total area there. Directions don't tell us what units. We don't, oh, sorry, this is area. This is areas in square feet. Remember, when we're measuring area, we're measuring how many squares fit in there. So area is square feet. How many little 1x1 squares would it take to fill this whole thing up? That's what area means. So there's a total area. Now, one little suggestion here as we do this, a little better way to do this, I want us to start to get used to this, is taking these two things and writing one formula and going to our calculator once. So we have area equals, we have the triangle, 1/2 times 22 times 7.333, throw another one in there, plus the rectangle, plus 22 times 10. So that includes the triangle and the rectangle part. So this area formula is the total area, and so let's make this total area. So we have one formula for the total area. So as we get into this, we're going to start making our own area formulas, basically. And once we write that in type that in the calculator, or write it as one formula, that is, we got one formula, type in the calculator once, put it all in there at once, and get your answer, 30.663. Okay, really round it off because we stopped there, so it's really 300.667 square feet, as we found out. All right, so we'll get used to that as we go. So we found the area. That was the answer to question 1. All right, so that's question 1. Let's go back up top here and look at question 2. So the question 2 is, how many sheets of plywood now do we need to cover that? So this is the first step to figure out some important building questions. So let's go back over here. To build this house here, underneath we have some plywood. So here's a picture of the house, the plywood underneath that. And so all these plywoods are rectangles or part of rectangles. And so to calculate this wall, we need to know how much area each of those rectangles covers. And that gives us a good approximate. So these are 4x8 sheets. Let's go back here. We can see that we've got some sheets of plywood here. See, I think it ends right there. And then there's another one right there. Okay, these are 4x8 sheets of plywood. And so we need to know how many of those sheets we need to cover this simple house here. Well, first thing we got to do is we got to say, well, what's the area of one sheet of plywood? And the sheet of plywood is 4x8, so it's a rectangle. 4 times 8 is 32 square feet. So the question is, if everything fit perfectly, if we use all of that plywood perfectly, which never happens, we can find the number of sheets by taking the total area and figuring out how much each one can cover. So 300.6667 divided by 32. And this will tell us how many sheets of plywood we need. So we'll go on over here to our calculator again. In fact, I already have that number in my calculator. So I'll just go enter there, answer, divided by 32. And so we need 100, oops, sorry. There we go, 9.39, all right? So we need 9.39 sheets. Now, can we go to the store and buy just 0.39 of a piece of plywood? 9.39 boards or sheets is really the better word. Okay, no, you can't just buy a 0.39 of a sheet. You got to buy the whole sheet of plywood. They're not going to sell you half a sheet. Well, they do have partial sheets, but we're going to buy full sheets is what we normally want. But so we're going to have, we want this to be 10 sheets, okay? We're going to round up. Now notice that's 0.39, and so, but we're still rounding up, okay? 9 sheets would not be enough, but if we have 10 sheets of plywood, then that will be enough there, all right? Great. So now technically we need to order some extras because when you put these pieces of plywood up, it's going to hang over kind of like this house here. You know, there's some sheets. I think there's one that's right about here. And so there was a part of this sheet of plywood that had to be cut off. You might be able to use that somewhere else, maybe, but most likely you're going to lose some plywood. So you just have to have some waste. It happens. All right. So now one more question is this. So how many 12-foot long pieces of siding do we need if we it has a 5-inch coverage lap siding? Okay, so what does that mean? Well, these boards here, and it's kind of fuzzy in that picture there now, especially when I zoom in, but so these boards cover a certain amount. So what we're saying here is that this is 5 inches, sorry. The board itself might be bigger, but the coverage, what it shows is 5. So we can imagine that these were strips of wood that are 5 inches by 12 feet, okay? And so one board covers a 5-inch by 12 sheet. So we need to find the area of one board. We're going to do this in a similar way, but the twist is here now that we have inches and feet, okay? So the lap siding, it's called, because it overlaps. All right, so we have the area of one board. Now, you're going to have lots of areas in these kind of formulas here, or these problems. So instead of just writing A equals, it's good to label, kind of like I'm doing in parentheses here. What is this, the area of? Keep your head on straight. So when you go back and look at it and fix things, you know what's going on. So we have 5 inches times 12 feet. It's a rectangle, 12 feet. So we got this long, skinny rectangle for our siding. It's 5 inches by 12 feet. Now, in order to compare this, we need to change this. All right, we need to change the units. And so the area that we've done up here is in square feet. So let's make this into square feet. So 5 inches. Well, 5 inches is less than a whole foot, right? Well, if we do this in fractions, it makes life really easy. 5 inches is what fraction of a foot? Well, hopefully you're thinking it's 5/12. Okay, and so instead of saying it's 5 inches, let's say it's 5/12 of a foot by 12 feet. Okay, now, well, this is just going to cancel. We can go to our calculator and do this, but this is just going to cancel. It's 5 divided by 12 times 12. This is just going to be 5. But we can convince ourselves over here with our calculator. And we can say, all right, we've got 5/12 times 12. Because you notice we just did 5 divided by 12 times 12. Those just counteract each other. It's 5, all right? So, great. So that's going to be 5 feet, all right? 5 square feet, that is. So one board covers 5 square feet. And we know we have 300, so the number of boards or lap siding boards is going to be 300.66, whoops, lost a 0. Okay, divided by 5. So we have our 300, oops. Okay, divided by 5. And so we need 60.132 boards. Again, you can't buy 1.132 boards, so we're going to need to round that up. So this is about, put some squigglies, 60.1 boards, but we're going to round that up to 61 boards because you got to buy a whole number of boards. Okay, it's called discrete numbers. All right, so that's the idea. Okay, so we can find the perimeter. I'm sorry, we can find the area. We didn't actually find the perimeter, but remember, perimeter is the distance around. If we wanted to find the perimeter of this, we would just find all the lengths and add them up. Okay, you would need some Pythagorean theorem for that. But so that's how we find the area. All right, so if you're breaking this into parts, you find the area of one part, and then you can just divide the areas. Now let me add one more version of this question. Sometimes you can do this math here. You know you got 12-foot boards, and you want to figure out how many boards you need. But sometimes you'll go to the hardware store, the lumber yard, and they'll say, all right, how many feet of lumber do you need, or how many feet of siding? So let's change this question and ask that. How many feet of siding, or we say how many linear feet of siding do we need? Okay. All right. So the way we do that is like this. So we're going to say this. We're going to imagine that this siding, sometimes when you buy boards, it comes in all different lengths, especially if you're talking about hardwood or something like that. And so, and when you cut these boards, you know, you cut them into all different sizes and things like that. And so, you know, really, it's not necessarily the number of boards we need. It's how many feet. So, if you imagine that these boards came from like this endless, giant rectangle. I'm going to put a squiggly. You're going to imagine that it goes on forever there. Okay, we got this huge rectangle, and it's 5 inches by X feet. okay? And we're going to go buy one board. And that one board, we're going to buy it, and then we're going to take that gigantic board and we're going to cut it up into all different size pieces we need. And that we're going to use those pieces to cover the house or the side of the house there. So this is the question that will tell us how many linear feet we need. Okay? Well, to figure this out, we need to say this. So the area of this thing, this long rectangle. Now, really, it's not going to be a rectangle. Really, it's going to be a bunch of pieces that if we stack it on end, if we put them end to end, they'd be different sized boards. But we have got this real long rectangle, all right? And we want to make sure that we have enough area in all those pieces to cover the side of the house. And so the way we do this is we can say the area here is 5 times x, actually it's 5/12 times x square feet. Okay, so it's 5/12 feet, because I'm going to change it to feet, times x. Well, we need that to be equal to the area of the house. So we need 300.6663, it was, right? Equals 5/12 times x. And 5/12, okay, 5/12 gives us 5/12, 0.416 repeating there, all right? So we have 300, we want to divide by 0.41, divide, because that's just 5/12. All right, and so we divide that out. So let's take 300 divided by that, and we'll have our answer. So if we take 300, really 300.6, and we divide that by the 0.416, we get 721.59. All right, so 721.59. So what that tells us is that we would need that many feet, 721.59 feet. And so that would be x, which we want to round that to 722 feet. Okay? So no matter what length of boards we get, if we got 12-foot boards, 16-foot boards, or whatever, 20-foot boards sometimes we get. And we need a total of 722 feet in length. And then that would cover it. Again, we would need to order some extra for the little cutoffs, because when we do this, there'll be little pieces that we'll lose. But 722 feet gives us a good idea of the length we need. Great. Well, so that's how we find the area, the total area. We find the number of boards and the number of lap siding. Okay, so all right, with that we can tackle some problems. So go from there, use some area, find some lengths of boards and pieces that you need there.